There are some things in Rust that can be confusing for a beginner, more because of the terminology rather than the actual concept. I think the slice is one of those things. The first time we encounter the term slice in the Rust book is chapter 4.3. Introducing the slice type, it says, "Slices let you reference a contiguous sequence of elements in a collection. A slice is a kind of reference." Remember, a reference is a type that contains the memory address of a value rather than the value itself. References and smart pointers are sometimes referred to as pointer types because they hold a memory address that points to where values are located. You can refer to my previous video on Rust memory management if you're a bit unsure about this. Use the link on screen or in the description. Here's a simple example of a variable I and a variable iref that contains the memory address of the value of I. The type of I is I32, and the type of iref is reference to an I32. You can have immutable references and mutable references, where mutable references allow the mutation or modification of the referenced variable. Here, iref is an immutable reference, so we cannot update I using iref. But in this case, we can update j using jref because jref is a mutable reference to a mutable variable. Immutable references are also called shared references because the memory address of the reference variable can safely be held or shared by multiple immutable references at the same time. Mutable references are also called unique references because the memory address of the reference value can only be safely held uniquely by a single mutable reference at any one time. Okay, so I suppose you're wondering, what's all this got to do with slices? Well, we'll need this terminology shortly when we look at a definition in the Rust language reference, so bear with me. The first example of a slice in the Rust book is a string slice, found in chapter 4.3. In this example, the type of variable SL is said to be a string slice, and it's created in a similar way to a reference, except that a range in square brackets is also specified, indicating that this is a reference to the 5 characters in the string S starting at index 0. Tying this back to the Rust book description of the slice type from earlier, we would say that SL references the contiguous sequence of the first 5 elements in the collection of characters in the string S. So the type of the variable SL is a string slice, and the string slice type is written like this. More generally, a slice can be created from a collection of elements of some type T. So the type of a slice created from a collection of I32 values would be written like this. String slices are so common in Rust that, as we can see, the type has its own name as part of the language. But the string slice is actually a wrapper over a slice of U8 values, with invariants that ensure valid UTF-8 string encoding. So the string slice is also a slice of values of some type T, where T is the U8 type. This is what a reference and a slice look like in memory. iref contains the memory address of the value of the variable I. And vslice, which the Rust book tells us is also a kind of reference, contains the memory address of the second element of the vec v. This is because we created it with its range beginning at index 1 of the vec collection, rather than index 0. vslice also contains a length field, which allows it to specify the number of elements it's referencing. So vslice references the values 22 and 33. Note that although I show vslice as having 2 fields called len and pointer, you'll not find these defined in the standard library source code. Unlike the vec type, that's fully defined by the standard library, slices are built into the Rust language and handled by lower level mechanisms than we need to be concerned with. I chose the names len and pointer because they serve the same purpose as the len and pointer fields of the vec struct, whose field names can be found in the standard library source code. But the memory structure of vslice is correct. Now we come to the main reason I wanted to make this video. If this type is called a slice, then what's this type called? Based on our understanding of references, we know it's the type being referenced by the slice. And so the answer is, well, actually, it's also called a slice. So that's a bit confusing. The Rust reference defines a slice as follows. So, by the official definition, the highlighted type is a slice. And it's a dynamically sized type. What this means is that it doesn't have a known size at compile time, only at runtime. For this reason, dynamically sized types, or DSTs, are also sometimes referred to as unsized types. A slice is dynamically sized because the number of elements of type T in the sequence is not specified as part of the type, and so not known at compile time. This means that you can't create a variable that's a slice as officially defined. So how do you use the official slice? Going back to the definition, it says, slice types are generally used through pointer types, for example as shown. And it calls this type a shared slice, often just called a slice. You could be excused for thinking this type would be called a reference to a slice. But no, it's a shared slice or just slice. What does shared mean here? Well, it means the same as shared when used in shared reference. That is, an immutable reference as we talked about earlier. So why are both of these types called a slice? And why are both of these types called string slices? The reason's simple enough. Slices are everywhere in Rust, and conciseness is greatly valued in the Rust community. The slice that's actually a reference type is much more common in Rust code than the slice as officially defined. So the term slice is assumed to have the more common meaning unless the context indicates otherwise. Slice types, as per the official definition, do serve a purpose in Rust code. One example can be found in the string implementation of the generic trait asRef. For conciseness, I'll refer to the official string slice type as stir and the common string slice type as refstir. The asRef trait definition specifies a generic type parameter t that must be supplied by implementations in order that a reference to a value of type t can be returned by the asRef method. The string implementation of asRef needs to return a refstir from the asRef method, and so for the type parameter, the stir type must be used. At no point is a variable of type stir created or returned by the method. That's impossible with a dynamically sized type. Thanks for watching, and please like and subscribe so that you don't miss out on the next video, which is on the subject of borrow and reference.